look at another example on the application of this trig functions or trig ratios to right angle triangles. Guys, in this case, I kind of wrote this whole statement, whole word problem here. It says we have a 20 feet ladder which is leaning against a house, and we want to find the height of the top of that ladder to the ground when we know already that the angle of elevation of the ladder is 60 degrees. So guys, the first thing we are going to do here is we're going to try to draw that right triangle, a scenario for our reference, and from there we should be able to figure out what we have to find. Okay, so we have let us think of this like a house, and I'm going to just draw a vertical line to represent this house. So, and this is like my horizontal, and let us say this ladder is leaning against this house, and let us assume this is like the top of the house right here, and the ladder is actually leaning against the top of the house. Okay, and then guys, the length of this ladder is 20 feet, so this is 20 feet, right? And then this is my house. This is my house, okay? This represents my house here. And then the angle that the ladder makes with the horizontal, the angle of elevation is 60 degrees. So it is like if somebody is right here, and you can think of this as like the angle line of sight, then the angle that the ladder makes basically with the horizontal is 60 degrees. And based on this information or this setup, we have to find the height from the top of the ladder. Now this is the top of the ladder, and in this case let us assume this is also top of the house. Guys, if you feel like drawing the ladder up to here, then you have to find that length. It is up to you how you want to draw it. I'm considering the ladder leaning against this house, like touching the house at the top. Okay, so in any case we have to figure out, in this case particularly, when we have this ladder touching the top, leaning against this whole the topmost part of the house, then we have to figure out this height h. Now guys, instead of this, if you have a slightly different figure, and let us say this is still your house, and you are leaning the ladder like this, not with the top, somewhere else, and this is still 60 degrees, and this is still 20. So guys, whatever you get here as an answer is exactly what you are going to get right here. Okay, that is not going to change. The difference is like maybe this house is bigger, taller than this one, so that does not matter. As long as you draw it clearly, you draw according to what the wording says, guys, you are going to get the right answer. Okay, so there can be more than one ways of drawing these things, but the thing that is important is you have to draw it correctly in a way that it has to look like a right triangle, and then it has to make sense. Okay, the angle of elevation is always the angle with respect to horizontal, so those are the things that you have to be careful with. So let me get rid of this, and so that we can actually do the work for this one. So once I have it in this form, now our goal is to find h. Now guys, it is not too difficult to figure out the height of this house, because we know that we have a right triangle. We have a right triangle here, and we have the reference angle. We can think of this as a reference angle. If this is my reference angle, then we know this is my hypotenuse and this is the opposite. So which trig function? So let me remind you all the trig functions. So, ka, toa. So sine relates opposite and hypotenuse here. Isn't this my opposite and this my hypotenuse? So I don't have to even go further to cosine or tangent. I can just right away use the sine function. So sine of 60 degrees equals to opposite over hypotenuse. Opposite here is the height of the height that we are trying to find, the top of the ladder, and divided by the hypotenuse, which is 20. So I have sine of 60 degrees equals to h over 20. To find this h, I got to cross multiply, right? Got to cross multiply. So we get h equals to 20 times, h equals to 20 times 20 times sine of 60. So h equals to 20 times sine of 60. Guys, we can do it in a calculator. We don't have to write this again. So 20 times sine of 60. So which is 20 times sine of 60. Make sure your calculator is in the degree mode. And guys, this is approximately 17.32. Does this have yes, it has the units feet, so it is 17.32 for, that's the height from the top of the ladder to the ground, which is this height right here. Okay, so it was not too complicated, guys, but you have to read the wording carefully, and then based on the wording we have to create a diagram, which in this case, in all of these cases, is going to be a right triangle, because this definition for the sine, cosine, tangent is only valid for right angle triangles. So we have to try to create that scenario, that visual which looks like a right angle triangle. Okay, so guys, I'm going to stop here with these application problems. In my next video, I'm going to start with another concept about the trig functions. Mostly it's going to be talking about trig functions for any angles. So far we were only confined to right angles and right triangles and also the acute angles. Now we will open it up for any type of angle. Okay, till then guys, take care.